Now we're going to look at a slightly more challenging case where we have two samples. We've sampled 1000 values twice or more, at least more than once. So we have sample 1 and sample 2. This requires that we make things slightly different, because for the indexer column, if you recall, the column we created here called value ID that we used as items, that column needs to be based on each existing observed value from both samples, both sample 1 and sample 2. Therefore, these values from these two samples or more samples must exist in the same column. The solution to that is to create an unpivoted version of the data table, which means that if I go to transforms here, I have enabled unpivot, and I've said that I want to involve my columns sample 1 and sample 2, which are numeric columns, and I'm saying that I want to use their original column names as a key or a name in one column, and the actual value goes into a column called value, and we see the end result here. So now we're sort of separating the samples by a label here, a key, name key, in this column, and the values are here. And this lets us, in the next step, on basically a copy of that table, which I have prepared, both create the calculated count column where we add a static 1 on each row to be able to make a calculation of the percentage or the portion value. And then we also have the value ID again. So we're using the source column value, and we're creating a numeric bucket which is based on identity, basically based on unique value, which we call value ID. And now this data table is in good order for creating a density plot that shows data from more than one sample. So again, we're creating a numeric line graph. We're putting the value ID on items, and we're putting sample on items as well, following the value ID. We are putting the value on the x-axis, and we're changing that aggregation to mean. And then the count goes on to visuals. And here things become a little bit special, because now we don't have one series, we actually have two. So we don't have one, we have more than one. So therefore we need to switch off this single series. Or in terms of aggregation, we don't want to use the calculation, but we want to use percent of total parent. So we want to show numbers which describe the percentage share of the sum of these ones in relation to all their peers in the same group, so per sample. And on the left axis, we want to use the format from the variable, and we want to give the variable additional decimals like that. And let's also color this by sample. So I'm putting sample on color, going back to visuals. I'm saying that for color, I want to use sample, and I want to use smooth lines, and I want to shade the area below the line. So here you can see we have sample 1, and we have sample 2, which is the red part. Let's also add the count to details and aggregate that as a sum. While it says count here currently, we actually should change that. So we want a title here which should be density, because that is what we have calculated. So now it says density instead, and it also says density in the details pop up. Looking at something else here, 34 observations having the value 117, which makes the probability that any randomly selected value from this sample would have the value 117, that probability is 0.034.